A common pattern in the functional programming is to chain functions or compose them. This means that we pass an argument to the first function, get a result, which is then passed to the next function, and so on until all composed functions are called. However, when composing functions together, our code might become difficult to read and to understand. Fortunately, we have a pipe operator in Reason, which enables us to write function composition in a concise and readable way. However, there's an issue with this operator. It's not supported by Sketch. And that's why we won't be running our code when using this operator. So I will be showing you compiler's output only in comments. Let's get started with an example. We defined three functions. The add function, which adds 5 to the passed argument, the multiply function, which multiplies the argument by 10, and the subtract function, which subtracts the argument from 200. Then we composed these functions together here and passed an integer argument to the add function. And we got back the result, which we immediately passed to the multiply function. Then we got another result, which we passed to the subtract function. And we got our result. As you can see, we are reading our code in right to left order. However, it's written the other way around. So it will be more convenient for us if we could write our code the same way we are actually reading it. And we can achieve this using the pipe first operator. This code works the same as the previous example. However, in this case, instead of manually composing functions together, we use the pipe first operator, which will perform the composition for us. This operator is written using a hyphen and this greater than equality operator. The pipe operator applies the expression on the left side of the operator here and passed it as the first argument of the function on the right side of the operator. In our example, we pass the integer argument to the add function, its result to the multiply function, and its result to the subtract function. And we get back the final result. As you can see, this operator is really convenient since it enables us to compose functions in a way we are reading the code. However, there's a convention that we don't turn the top level function call into a pipe, so we should rewrite our example like this. Instead of the first pipe, we pass our argument to the add function using parentheses. The pipe operator is commonly used when performing operations on lists. Let's take a look. In this example, we use three predefined functions from a list module to transform a list. List.flatten and list.ref expects a single list parameter, while list.filter expects a function and a list. To be able to use list.filter in our composition, we needed to partially apply it by passing it a function, as you can see here. As you can see, we use the pipe operator to compose our functions. We took a list of lists expression and passed it to the list.flatten, which flattened our list. Then we passed this flat list to list.filter, which filtered out elements smaller than 2 using the passed function. Finally, we passed the filtered list to the list.ref, which reversed our list, and we got back our final result. At least this is how we think our function should work. If we run this code, we will get a type error telling us that we are passing a list instead of a function. And this error refers to the filtering function. List.filter expects 2 arguments, a function and a list. And we partially applied a function, and later we passed the list as well. So why are we getting this error? It's because the pipe first operator applies the value as the first argument of a function. So in the case of list.filter, it passes the list as the first argument to the list.filter function. That's why we are getting this type error. Let's fix our code. As you can see, we fixed our code by wrapping the filtering function inside another function. And our code finally works. We wrapped the list.filter in another function expecting a single list argument. And when this function is called using the pipe operator in the composition, it receives the list argument. Then it will pass this list as the second argument to the list.filter. And the filtering function will be passed as the first one. Because we fixed the order of arguments, our code works, and we got back the result of our composition. However, this code is unnecessarily verbose. Fortunately, there's a cleaner solution we can use to fix our code. But first, let's take a look at how we can use a placeholder in function. We defined the subtract function, which subtracts 2 arguments. Then we applied it partially by passing it an integer. However, we are not partially applying the first argument, but the second one. We used a placeholder as the first argument, which is written using an underscore, and then we filled in an integer as the second argument. By doing that, we are telling the compiler that we want to apply only the second argument because we don't know the first argument yet. Finally, we passed another integer to our partially applied function, and this integer will be used instead of the previously passed placeholder. So it will be applied as the first argument to the subtract function. And 4 minus 3 is 1. So if we want to call a function and we don't have all the arguments at the moment, we can use the placeholder instead and fill in the missing argument later. We can use this placeholder to solve our previous issue as well. And let's also remove this last example. Our problem was that the pipe first operator applies the value as the first argument of a function. However, in the case of list.filter function, we needed to apply the value as the second argument. So we can use a placeholder to show which argument we would like to pipe into. In our example, we are using a placeholder to tell the compiler that we want to pipe the last argument, because list.filter expects the list as the second argument. And as you can see, our code works. And this code is pretty readable because it's written the same way we are reading it, and each composed function is nicely separated by the pipe first operator. Moreover, the code is much shorter than the version where we wrapped list.filter in another function. The pipe first operator can be also written using different syntax. Let's take a look. As you can see, our code still works the same. It's just a syntax difference. However, this second version is now deprecated, so we should be using the first one. There's a second type of a pipe operator in Reason. Let's take a look. This operator is written using a pipe and this greater than equality operator. And we can use it just as we use the pipe first operator. However, there's one difference. As you can see, we are not using the placeholder when calling the list.filter anymore. This is because this pipe operator applies the value as the last argument of a function. So we don't need to use a placeholder because this operator applies the list as the second argument to list.filter automatically. So the pipe first operator applies the value as the first argument of a function, and the regular pipe operator applies the value as the last argument of a function. Using the pipe first operator is the preferred way of piping in Reason. And there are two main reasons for that. The first one is because of a library called Belt. This library is becoming increasingly popular, and there's an idea that it will become the standard library for Reason. All the predefined functions we used so far, such as functions from the list module, were part of the OCaml standard library. And you can think of Belt as an alternative to it. It contains many functions that can be found in the OCaml standard library as well. So, why using Belt instead of the standard library? Compared to OCaml standard library, Belt has better performance. One of the main differences between Belt and OCaml library is the order of arguments of functions. Functions in belt expect the primary argument as the first parameter. And by the primary argument, I mean, for example, a list in the filter or map function. On the other hand, for example, list.filter from the OCaml standard library expects a list as the second argument. So when using functions from belt, we are using the pipe first operator a lot because of the argument order. Because when using the belt library, most of the time we are passing the primary argument as the first argument to the function, and the pipe first operator will do exactly that. And if you think about it, belt's argument order is similar to that of predefined functions in JavaScript. This is not a coincidence, since belt was written with the JavaScript in mind. The second reason for preferring the pipe first operator is that reason is commonly used with wrapped JavaScript code. And, as we've just mentioned, JavaScript methods use the same argument order as belt.